shall continue the discussions on generative adversarial networks and adversarial learning. So the next component that we are going to look at is inversion with GANs. Inversion with generative adversarial networks. So in a naive GAN, which we saw so far, we can generate data from an arbitrary input space. So typically what happens is that we have a generator which samples from the distribution of interest, which is our data distribution. So the input to this generator are samples from normal distribution, and this will give you samples from the distribution of interest, right? This is p theta of x, which is close to px. That is what we have been doing so far. Now suppose we want to invert this process. What does that mean? So I'll write that down. A GAN in its naive formulation is a function, or rather we'll say a trained GAN. A trained GAN is a function from Z space to the data space, right? That is what it does. It takes an element from normal 0, 1 and it maps it into the data space. Now suppose one is interested in inverting the above process. Inversion of the above function. That is, given an image or given some data point, let's say xi that is sampled from px, okay. Goal is to find the corresponding z. Okay. What do you mean by finding a corresponding z? That is, find a z, okay, such that g theta of z is equal to xi. Okay, let's call this zi. Okay, we want to find a particular zi such that when that particular zi is passed through the generator, the trained generator, let us indicate the trained generator by g theta star, okay, because the training has been done and we have a fixed theta star. Now what do we want to do is, suppose you are given a data point xi, the goal is to find the corresponding z, that is that z which would have generated this particular data point xi. Okay, so this problem is known as the problem of inversion, where we are not interested in generating a data point from a latent variable. Rather, we are interested, or rather, we are not interested in generating a data point given the input Gaussian vector. Rather, we are interested in finding out which is the vector from the Gaussian distribution that would have generated a given particular data point. Okay. Now, if you look at the formulation, the naive GAN formulation, there is no provision to do this, right? Post training, what we can do is we can sample a data point from the normal distribution and get a sample that is generated from the generator. However, there is no way that we can invert this particular process, where given a particular input data point sampled from px, we cannot get the corresponding z. Now the question is, how to modify modify a GAN such that the inversion is possible. Okay, we will look at a couple of approaches to solve this problem. So before we look at the approaches to solve this problem, let me just motivate you so as to why this is of importance. Now, why does one need the corresponding input variable for a given data point? There are two reasons why one would look at inversion. So one is, okay, so maybe before we take up this question, let us answer that. So inversion is useful for there are multiple use cases, but I'll just list two of them. Inversion is useful for one, feature extraction. So what do I mean by feature extraction? Now we know that a GAN is constructed to sample from a given distribution Px, data distribution Px, which means that if we have trained the GAN well, then it has implicitly learned the distribution of the data, which means that the corresponding, if we can invert the generator function of the GAN, then the vectors that we would be getting from the generator, or by inverting the generator, will be representing the features of the data. Okay, so which means that if we can somehow get this function, get this inversion done, then we can take a data set and do an inversion using this particular GAN, and all the vectors that we get post inversion would correspond to some sort of feature representation of the data, right? So feature extraction, which is that, so inversion is useful for feature extraction, which is given a data set, obtain GAN inverted vectors and use them as features. Use them as features for data. So we also know that the dimensionality of Z would be typically much lesser compared to that of the data, which means that if we invert, then we will be getting a lower dimensional feature representation of the data. Okay, and that can be used for classification, that can be used for any other downstream task involving the data distribution. So that is one reason why we would want to invert the GAN. The second possible use case for inversion is data manipulation or editing. So what is meant by this? Think about it. Let's say that I have given a particular image. Okay, let's say that we are building a GAN for an image data set, and post training, suppose we are given a particular image. Now the question is, can I edit this image using GAN? Right now, a naive GAN will not support any editing tasks, because a naive GAN can only take a vector from a Gaussian distribution and generate data. But if you want to edit a given particular image, okay, then one first needs to get the corresponding input inverted vector representation of a particular image, and then edit the corresponding input vector, and then generate the new image, the edited image, after editing, after manipulating the input inverted input vector. Okay, so that would possibly enable editing in a GAN. So what do I mean by that? Suppose Suppose what we want to do is that we want to edit xi, okay, or manipulate xi. Suppose xi that is from px needs to be manipulated or edited. So what do we do? First we get the zi, okay, corresponding to this particular xi via inversion. Okay, we first get zi corresponding to this particular xi via inversion. So this xi should be equal to zi. Get, one needs to first get zi, okay, such that xi is equal to g theta star of zi via inversion. So I'll tell you how to do this inversion. We'll first get the corresponding inverted zi, then do z edit, okay, is some function, okay, let's say f edit, some deterministic function that is applied on zi. So this f edit can be anything, it can be addition, it can be some traversal starting from zi, any kind of edit function that is there. Okay, then so get x edit as g theta star of z edit. Okay, this is the idea. So the idea of manipulation, data manipulation using GAN inversion is to first get the inverted input vector, okay, using the inversion process, and then manipulate the inverted vector using some edit function, so which can be anything, and use that edited input vector in the generator to generate the edited input image or input data point. So that is how one manipulates the given input data point using GAN inversion. So therefore, inverting a GAN, which is finding out what is the input vector that would have generated a particular given data point, is of importance. Okay, so there are two possible applications. There can be multiple other applications as well, but two possible applications are that one, it can be used for feature extraction. Okay, the other application where inversion is useful is where one needs to manipulate or edit the data. Okay,